There's 100 meters until we get to sea level. This is a place that it's been impossible to get to in the past.
What if I told you that engineers have built highways and high-speed rail lines under the ocean, some stretching more than 10,000 meters, where cars race through glowing underwater corridors and bullet trains shoot across the seabed at incredible speed? In this video, you'll see the Qingdao Jiaozhou Bay Tunnel, where 140,000 vehicles travel under the sea every day. The Shenzhen Zhongshan Megatunnel, built with the world's heaviest immersion sections. The massive Bohai Strait Tunnel, planned to be longer than the Channel Tunnel. The Jintang High-Speed Rail Tunnel, designed for trains flying underwater at over 250 kilometers per hour. The Shiziyang Tunnel, built through some of the most unstable geology on Earth. And the Zhuhai Undersea Tunnel, where robotic systems work non-stop to keep the ocean out. These aren't future concepts, they're real megastructures, already reshaping China's coast. And American engineers who inspected them were stunned, admitting they'd never seen underwater engineering done at this scale, this speed, or this level of precision. Qingdao Jiaozhou Bay Tunnel. The Qingdao Jiaozhou Bay Tunnel is one of China's most impressive engineering achievements, a megastructure that pushes the limits of underwater construction. Stretching nearly 8 kilometers beneath the seabed, this tunnel connects the city of Qingdao with Huangdao District, slicing travel time across the bay from 40 minutes to just 10. But what truly makes this project extraordinary is the environment it had to conquer. The seabed beneath Jiaozhou Bay is anything but stable. It's made of soft sediment, shifting sands, and sections of unpredictable geology, the exact kind of terrain that engineers usually avoid when attempting an undersea tunnel. Yet China decided not only to build here, but to build one of the longest submarine tunnels in Asia. Construction began with a challenge that most countries would consider impossible. Teams had to dig through unstable layers while preventing millions of tons of seawater from bursting into the tunnel. To do this, engineers used a combination of massive tunnel-boring machines and advanced drilling techniques, supported by a constant flow of high-pressure concrete grouting to stabilize the surrounding ground. Every meter had to be reinforced to ensure the structure would survive long-term pressure and seismic activity. One of the most impressive features of the tunnel is its depth. At its deepest point, the roof lies more than 70 meters below the water's surface. At that depth, the pressure is intense, and even a small structural weakness could have caused catastrophic flooding. Engineers spent years perfecting the waterproofing system, using multiple layers of steel, concrete, and rubber sealing rings, creating a protective barrier strong enough to resist ocean pressure, earthquakes, and corrosion for decades. Inside, the tunnel is designed for high traffic flow, carrying 3 lanes in each direction. Sophisticated ventilation systems constantly circulate fresh air, while a dense network of sensors monitors temperature, stress levels, wind flow, and even chemical gases in real time. If anything unusual happens, from a car breakdown to a minor vibration, control rooms receive alerts instantly. High-definition cameras, emergency escape routes, and automatic fire suppression systems make this underwater highway one of the safest in the world. But safety wasn't the only goal. The tunnel was built to dramatically reshape the region's economy. Before it was completed, traveling between the two sides of Jiaozhou Bay meant long drives around the shoreline or congested ferry trips. The tunnel changed everything. Commerce, tourism, and logistics increased rapidly, and the project became a backbone of development for Qingdao, one of China's most important coastal cities. What truly shocks foreign engineers, however, is the speed at which the tunnel was completed. A project of this scale would normally take decades, but China finished it in just over 4 years. That combination of ambition, technical expertise, and rapid execution left American and European engineers surprised, even impressed. The Qingdao Jiaozhou Bay Tunnel is more than an underwater passage. It is a symbol of China's rising engineering capabilities and a preview of even bigger undersea megaprojects still to come.
Shenzhen Zhongshan Undersea Tunnel. The Shenzhen Zhongshan Undersea Tunnel is one of China's most advanced underwater megaprojects, built to connect 2 major economic powerhouses across the Pearl River Delta. Stretching over 6.8 kilometers beneath the seabed, this tunnel forms part of a massive 24-kilometer cross-sea link that combines bridges, artificial islands, and the world's first large-scale immersed tube tunnel built in deep waters with strong typhoon zones. Engineers faced extreme challenges here. The Pearl River estuary is known for turbulent tides, soft seabed layers, and powerful seasonal storms. To survive these conditions, China constructed huge prefabricated tunnel sections, each weighing more than 70,000 tons, and carefully lowered them into a dredged trench on the seafloor with centimeter-level precision. Once connected, the joints were sealed with high-pressure gaskets designed to resist seismic movement and long-term saltwater corrosion. Inside, the tunnel carries an advanced smart traffic system, LED navigation lighting, intelligent ventilation, and emergency escape passages built to international safety standards. When completed, it will cut travel time between Shenzhen and Zhongshan from 2 hours to under 30 minutes, transforming the Greater Bay Area's transportation network. The Shenzhen-Zhongshan Tunnel stands as another example of how China is redefining undersea engineering on a global scale. Bohai Strait Tunnel. The Bohai Strait Tunnel is one of China's most ambitious transportation projects ever proposed, a megatunnel designed to link the Liaodong Peninsula with the Shandong Peninsula directly beneath the Bohai Sea. If completed, it would become the longest undersea tunnel system in the world, surpassing even the Channel Tunnel in Europe. The full route is planned to stretch over 120 kilometers, with more than 90 kilometers running underwater, making it a project of unprecedented scale and complexity. What makes the Bohai Strait Tunnel so astonishing is the environment it must overcome. The Bohai Sea is shallow but extremely active, with unpredictable currents, seismic activity, and heavily layered geology beneath the seabed. Engineers would need to bore through hard granite, soft sediment, and fault zones, all while preventing water pressure from collapsing the tunnel. To solve this, China's plan involves a combination of immersed tube sections, deep-bored shield tunnels, and emergency access passages running parallel to main traffic tube. The tunnel is expected to support high-speed rail, allowing passengers to travel from Dalian to Yantai in under 40 minutes, compared to the current 8-hour ferry ride. This connection would merge two major economic regions, strengthen northern China's logistical network, and potentially open a new corridor for Eurasian freight movement. While the Bohai Strait Tunnel is still in phased preparation and geological research, the concept alone has stunned global engineers. If China succeeds, it will redefine the limits of undersea construction and mark one of the greatest engineering achievements in modern history.
Jintang High-Speed Rail Tunnel. The Jintang High-Speed Rail Tunnel is a monumental feat of modern engineering connecting Jintang Island to the mainland as part of China's expanding high-speed rail network. Spanning over 26 kilometers under the sea, this tunnel isn't just a transportation link, it's a symbol of China's ability to push the limits of undersea construction. Designed to carry trains at speeds of up to 250 kilometers per hour, the tunnel drastically reduces travel time between Jintang Island and nearby urban centers. What makes this project truly astonishing is the challenging marine environment engineers had to conquer. Beneath the East China Sea, workers faced high water pressure, soft seabed sediment, and seismic activity, all of which made boring a tunnel extremely difficult. To overcome these obstacles, the construction team used advanced shield tunneling machines equipped to handle both soft mud and hard rock layers while maintaining tunnel stability. Safety was another crucial challenge. The tunnel includes state-of-the-art ventilation, fire safety systems, and emergency exits, ensuring passengers can travel securely beneath the sea. During construction, precision monitoring equipment tracked ground movement and water pressure in real time, preventing potential collapses or leaks. Since its completion, the Jintang High-Speed Rail Tunnel has transformed regional connectivity, turning a journey that once took hours into a smooth, fast ride. Beyond its practical benefits, it stands as a global benchmark in undersea engineering, inspiring engineers worldwide to rethink what's possible in long-distance tunnel construction. The Shiziyang Tunnel. The Shiziyang Tunnel is one of China's most impressive engineering marvels, stretching over 10 kilometers under the Shiziyang section of the Pearl River. Built to connect Guangzhou and Shenzhen as part of the high-speed rail network, this tunnel isn't just a transportation route, it's a testament to China's mastery of undersea construction. Designed to carry trains traveling at speeds up to 350 kilometers per hour, the tunnel dramatically shortened travel time between major cities, providing commuters with a fast, reliable alternative to bridges and ferries. But constructing an undersea tunnel of this scale came with massive challenges. Engineers had to work beneath deep riverbeds, strong water currents, and soft, unstable sediments, which threatened to collapse the tunnel during construction. To overcome these obstacles, the team relied on cutting-edge tunnel boring machines, TBMs, capable of excavating through mixed soil conditions while simultaneously installing reinforced tunnel linings. Continuous monitoring systems tracked ground movement, water pressure, and structural integrity, ensuring every meter of the tunnel was secure. Safety systems were also a priority, with ventilation, emergency exits, and fire suppression technologies integrated throughout the tunnel. Since opening, the Shiziyang Tunnel has revolutionized regional transportation, handling thousands of passengers daily while maintaining exceptional safety and efficiency. Beyond its practical benefits, it has earned global recognition as a pioneering achievement in undersea high-speed rail construction, inspiring similar projects worldwide. It's a prime example of how China is redefining the limits of engineering under extreme conditions.
Zhuhai Undersea Tunnel. The Zhuhai Undersea Tunnel is a breathtaking feat of modern engineering connecting Zhuhai City to its surrounding regions beneath the South China Sea. Stretching several kilometers underwater, this tunnel is a critical artery for both commuters and freight, providing a fast, reliable, and weatherproof alternative to ferries and bridges. Constructing an undersea tunnel of this magnitude posed enormous challenges. Engineers had to navigate deep water pressure on stable seabeds and strong tidal currents, which made traditional construction methods nearly impossible. To overcome these hurdles, they deployed advanced tunnel boring machines, TBMs, designed to cut through a mix of sand, clay, and rock while simultaneously reinforcing the tunnel walls. Every segment of the tunnel was carefully aligned with precast concrete segments, ensuring structural integrity against both water pressure and seismic activity. Safety and efficiency were paramount in the Zhuhai Tunnel. State-of-the-art ventilation systems, fire suppression units, and emergency evacuation passages were integrated throughout to protect travelers in case of emergencies. Sophisticated monitoring systems track water pressure, structural stress, and ground movement in real time, making this tunnel one of the safest undersea passages in the world. Since opening, the Zhuhai Undersea Tunnel has reduced travel time dramatically, connecting Zhuhai to nearby cities in minutes rather than hours. Beyond its practical impact, it stands as a symbol of China's engineering dominance, showcasing their ability to conquer extreme challenges beneath the ocean. The tunnel not only transforms transportation, but also inspires the global engineering community to push the limits of undersea construction.